First of all, thank you all for joining me today. I know it's going to be late. And I have the honor of entertaining just before the party, and so I'll try to do the best I can to keep you all awake. And since I'm here just before the party, I decided that I should have a more appropriate picture here, if this works. Here we go. That is me, drinking beer. I'm from Denmark. We do that a lot. So you already heard a lot about the cool parts around GraphQL, and you've heard about the transformative benefits of GraphQL in general. So I'm going to take you to a little bit of a darker place this time around, even though the slides will be brightly colored as I work for a toy company. But this is going to be a talk that I hope that someone would have given me like 6 years ago. It's not going to be really advanced, and some of the guys that are in here will probably know about a lot of these error handling techniques. But see this more as friendly advice from someone who's seen his fair share of mistakes over the years. So the topic of today is pretty critical, but often overlooked when you're looking into GraphQL development, and that's error handling, of course. So a little backstory is probably needed here. I've been an engineer for 22 years now. I'm getting old. And I've spent the last 10 years working primarily within the streaming industry, focusing on building APIs that are aimed straight for the end consumer. Now, when you're working within that industry, a lot of things can go wrong when you're exposing data. And things tend to get a little bit messy if you have errors that are being bubbling up to the actual UI for end users. So these are all error messages that I've either authored or have somehow surfaced through some of the APIs that I've been involved in over the last 10 years. And as you might imagine, these errors aren't really something that's meant for an end user to actually see them, but it has already happened, several times. And I'm going to get back to a little bit about why this can happen, and of course, you don't want your end user watching things like this if they're just trying to watch TV. But before we go into that, let's have a look at some of the main types of errors that we encounter when we're consuming data through GraphQL. So this is a pretty simple query, and as you might notice, we're missing something here. So if I try to run this is what I get back. Now, most of the time, if you're running things like this through Playground or Apollo Explorer, things like that, your editor will oftentimes actually warn you about this. And this is like a basic syntax error. Now, these occur whenever your GraphQL query can't really be parsed due to an incorrect syntax. This is typically happening when you're doing things like you're missing a bracket, or you have some error in the way that you're trying to get a field name, for instance. Okay, so we fixed the missing curly bracket here. Now we're going to try to do this again. Now, unfortunately, this time around, we're getting what's called a validation error. And the validation error occurs here because apparently no engineer has even started to work on the cat query yet. And I'm saying yet because, of course, you need a cat query. And the validation error that you're seeing here is what typically happens when the query that you're trying to execute doesn't really align with the schema that's provided on the server side. So in this case, it could be requesting a field that doesn't exist. OK, so now let's assume the schema here is modified to actually support looking up cats. However, things can still go wrong, and we will end up with something like this. So what this is basically an execution error, or what's called a resolver error as well. These happen during the resolve execution phase and can cover a lot of different things, typically exceptions that are thrown in your business logic, database connection failures, all sorts of funny stuff. And the tricky thing about the resolver errors or the execution errors is that they can cover a lot of different things, which also makes them pretty complex to actually handle or to consume from the consumer side. Now, as you'll also notice here, as you probably know, GraphQL will by default have errors being populated in the errors object, which is pretty cool because that makes GraphQL able to actually return some data and return some error, which is what we like because you can get like partial data back and then potentially an error back. But that behavior is often one of those things that can lead to some confusion when you're talking to consumers of data. Okay, so we had a brief look at some of the few errors that can occur when you're executing GraphQL. Now let's have a look at some of the most common mistakes that occur when you're trying to consume these errors and why these actually happen. So first up, assuming complete failure. I've seen that a few times. And what this is if you have, let's say you have a consumer application that's running on iOS or Apple TV or something like that, and the engineer that has been building this client application expects you to have no errors back. And as soon as something happens within the errors object, they basically say, okay, I'm going to fail completely. This is critical. I'm getting errors back. This doesn't work. And they either throw an error to the end user or the application crashes or something like that. I've seen this happen quite a few times. And it's basically kind of a binary approach where you're either this works or it doesn't, which often happens to data consumers that aren't really used to consuming data through GraphQL or not aware of the fact that you can have partial data back and errors related to that. Now, the second thing is exposing the user to harm, or at least slightly inconvenience them by throwing the error straight to the UI. Now, this typically happens if someone has done debugging in an application and they've decided, well, I'm just gonna output whatever errors I get back because I'm just doing this in development. And then all of a sudden, this thing is running in production and it's being deployed somewhere to end consumers, and they'll end up seeing the error here. Now, one part of that is, of course, that this is confusing for the end user actually seeing the error. But the other part of this is that this could actually end up being a way that we will expose some sensitive information that we have around the way that our API works. So in this case, what we could end up in is a situation where we're exposing information about our infrastructure, the way that our network works, things like that that could be useful for anyone who wants to do us harm. And finally, the fact that errors are not directly associated with the data fields that they represent can oftentimes cause some confusion. Now, imagine, if you will, you're doing a request where you want a list of 10 movies back. Now, 3 of those movies are actually causing some issue. It's causing an error, and you get some errors back in your errors object. Now, you get a list of 7 movies back, but you have no clue which 3 movies are actually missing because the errors that you're getting back have no real relationship to the actual data existing in your data object. And this oftentimes means that the consumer of your data, the application engineers that are building an application, will have a more complex setup on their hands because they have no way to actually merge the errors with the data that they're getting back. Okay. So the mistakes that I've mentioned here will at bare minimum be an annoyance to whoever actually gets to see this. And as I mentioned before, the worst case that could happen in these cases are that you will expose some data to the end user, or potentially revealing something that's sensitive. Okay. So we talked about the different types of errors. Now let's have a look at some of the ways that we can actually mitigate those or handle them a little bit better. So first off, hiding implementation details. And the person in the bottom right corner there is, of course, trying to steal your diamonds or secrets, whatever. So as I mentioned in the beginning, one of the main issues of missing error handling is actually exposing sensitive data. And we don't really want potential attackers to actually have this information around our infrastructure. So a good way to avoid that would be to actually look at the errors that you might throw in your setup and what data they are actually providing through the API. So a simple example of this would be to have a way of splitting your errors in what are you actually logging for debugging purposes, what are you actually reporting into your debugging system if you have one of those, and then what are you actually exposing through the API. So in this case, instead of having database connection errors thrown directly in the API, you can mask those, reporting something more generic back to the end user or the consumer, and then just having the logging purposes for debugging. And the main point here as well is if you have errors in your setup, it's a really good way to actually look at all of those errors and try to figure out what would the consumer actually benefit from knowing here. So what's the least amount of information that they'll need to actually remedy this? And then if you have to do, let's say, a specific error that the client will have to act on, then you could do something where you introduce error codes or something like that that's unknown to the actual end consumer, but only known for the client application engineers. Okay. So actually hiding the details here is pretty straightforward. Now this is a simple example of how you could actually mask those if you're using things like Apollo Server. Now, Apollo Server has a thing called format error that pretty much allows you to take whatever error is being thrown in your setup and rework that. So in this case, what it does here is it basically just looks at if this is production, I'm just going to rewrite the error and throw some more generic error back. And in this case, you could also throw in the logging, as I mentioned before. You could do that within this check, of course. And also having this in a centralized position or a centralized place in your federated setup will basically allow you to handle all of these errors in a uniform way across your entire setup to avoid those bleeding out to the end consumer. All right. So we talked a little bit about hiding implementation details and masking of errors. Now, let's try to dive a little bit into the magic of union types. So union types can be quite a bit of a game changer in the way that you actually handle errors. And it can be a pretty good companion when it comes to actually handling the decoupled errors that I mentioned also in the beginning. So, in the first example here, we have a movie query, and we're expecting that to return a movie. Now, if something goes wrong, I will probably get nothing back, but I'll see some error in the error subject. Now, if I move to a union implementation of this, what I could do instead is have the movie result. Now, this basically allows us to have multiple possible return types for the field that we have. So in the case of error, what this basically does is it allows us to return either the expected data, the movie object, or some error object representing what went wrong. Now, the cool thing about this is that we can map out every single potential error that's going on whenever we're requesting a movie. So if we move on to the resolvers, so in this case, what we then would do is that we would check for some different types of things that could go wrong here. So in this case, what it does is that it basically looks for simple things like, is this user authenticated? If they're not, well, then we'll throw an authentication error object back. And if the movie isn't found, we'll throw back a movie not found error, of course. And in case the movie is actually working and everything's fine, we'll throw back the movie object. Now, what this could be used for in the client is that instead of having to check the errors object, we can use fragments here to actually have a more graceful approach to actually handling these errors. So in this case, the client can actually respond to the different types of errors. Here we are just requesting the message for each error if something occurs. And then, of course, if you get a movie back, you will have the regular logic of handling that. Now, the great thing about this is that the objects here will be returned in place, which means that in the case of the 10 movies that I mentioned before, if you're using a way of the technique like this, what you would see is then you would see a list of potentially 10 movies or like 7 movies, and then these different error objects in the middle of those. This allows you basically to have a better user experience as you can act on the errors in the place where they're actually occurring. Okay, so using union types gives us a few benefits. And so first off, it's pretty explicit. It allows you to actually define all the potential responses that you want, which makes it a lot easier for the consumers of your API to actually know what they're getting back. You're basically promising them you will get either this object back or you will get some kind of error object back. And in the same sense, it allows you to have a more safe set of types, especially if you're working with something like TypeScript or another type strong language where you want to have something that's mappable onto an object once you get back and not have to do error mapping based on the errors object. And finally, as I also mentioned before, what this does is it allows the client to actually act in a more graceful way on the errors instead of having to traverse the errors object, instead of having to do what I've seen done, string matching on error messages in the errors object, things like that. So this, using union types actually allows you to do that a little bit more gracefully. Okay, so just to sum up a little bit about what we've been through for the last 18 minutes, I just wanted to go through a few key points in terms of getting your error handling a little bit forward. So based on the patterns that we talked about. So first off, avoid doing too many error types. So try to define the errors that you actually want based on what your consumers of the API actually need. So avoid having too many different error types because that's confusing for everyone who's trying to consume data through your API. And in the same sense, should you just expose raw errors? No, you should not. You should, of course, consider the different severity levels of the errors that you're actually throwing. So if you're throwing something that might be a critical error, how do you handle that? That might be different from the way that you're handling what might be a slight inconveniencing error. So have a look at all your error types and look at how critical are the errors and what's actually needed to provide some context for the consumer in order to act on those errors. Should I use unions for errors? You probably should, but keep it simple. Unions are pretty powerful, but if you do those, if you overdo it, you end up having a lot of different types, and you will have a lot of error types that no one's actually using or that's basically conveying the same message. So there's a limit to the amount of some object not found error types that you should probably have in your schema. And finally, should you misuse your errors object and just throw in whatever you can and just log it? No, you shouldn't do that. What you should do instead is that you should try to move through the errors that you know is happening in your setup. And that can be a pretty hard thing to do if you have like a federated setup with a lot of subgraphs. But try to figure out what errors are being thrown and what are the different levels of information that's needed, and then use the tactics that I've mentioned to try to handle them in a more graceful way. Okay, so I'm just going to end this on a quote by the almighty Uncle Bob. And I'm just going to mention that effective error handling isn't really about preventing failure, because you really cannot. Failure will always happen, and you just have to adapt to that. So instead, what effective error handling is about is ways of actually building the trust with the data consumers that you have. So instead of avoiding failure, try to build up trust with the data consumers that you have and make them comfortable in actually consuming data through your API. Now, I encourage everyone here to actually go back and review some of the current error handling strategies that you might have and see where you can make improvements, because I'm guessing you can probably do that a lot. Thanks.